All right, welcome everyone. Thank you for being punctual. We're very happy today to have Aniko Ori as our speaker. Aniko is an associate professor of marketing at Yale SOM. Her research interests focus on industry organization, quantitative marketing, and microeconomic theory. In particular, she's interested in the analytical modeling of dynamic interactions of firms with customers, including dynamic pricing in environments with asymmetric information structures. And we are equally happy to have Matthew Ellman, Senor Ellman, from Institute of Economic Analysis at Barcelona Graduate School of Business. So as a reminder, the seminar will run for an hour. We will begin with a 45-minute seminar, followed by Matthew's discussion for 5 minutes, and then a 10 minutes Q&A session. So questions should be typed into the chat. I'll be watching the chat closely. Aniko has included several pause slides during her talk, during which I will ask clarifying questions on your behalf if there are any in the chat. So during the Q&A, depending on the volume of the questions generated during the talk, I may call upon you or use my discretion and integrate multiple questions for Aniko. I will private message you beforehand your position in the queue to speak. You can also command me to ask your question. So lastly, note that the seminar will be recorded. And so if you don't want to be recorded, you shouldn't ask a question. All right, Aniko, the floor is yours.
Thank you so much for the nice introduction, and also for Matthew for discussing the paper, and for the organizers for having me. So this is a joint work with Joey Depp and Kevin Williams, who are both my colleagues at Yale SOM. It's on crowdfunding. And for those of you, as a reminder, who don't know this cool mechanism, it's reward-based crowdfunding is a mechanism that allows entrepreneurs and company or people with ideas to access funds from their customers before actually launching it. And a typical campaign consists of a product that you want to sell, a price, and a fundraising goal, and a deadline by which you want to raise that money. And then the cool thing is that the backers only receive the product and pay the price if the goal amount is raised by the deadline. The largest platform is Kickstarter, which was launched in 2009. They have pledged. They have received 5.3 billion in pledges, 18 million people, and close to 200,000 projects. This might sound relatively small, but for example, so many of those companies, such as Pebble, which you might know, actually become very successful and have many, are much bigger now. So it can have a very big impact. The categories or industries in which they perform, it's very wide-ranging: technology, video games, comics, films, music. So all kinds of things, and the dynamics and the things that we will discuss will apply to all of them. So it's a really nice algorithm which can be applied to many things. Now here's an example from a case that one of my colleagues and friends at Wharton, Ron Berman, has written on United by Blue. So their first campaign was for an organic bike bag. So you have a picture and product description usually on one side, and then on the other side you have the different buckets. So here I only put one bucket because I will not talking about bucket. So Matthew is an expert on that, on price discrimination in that dimension. But here we have so here I only put the one price, so you can buy it for $60 and pledge. And one thing that I want to emphasize is, and that we didn't know before we started working on this project, is that there's this option that says make a pledge without a reward. So you can just put any amount of money in there without receiving the product in exchange. And so the interesting thing here was that in the first campaign was $1,000 short at the deadline or close to the deadline, and then somebody, so probably the mother or the father of the CEO, some friends and family, donated in order to reach the $15,000 goal. And so afterwards, they had many more campaigns that were very successful. And yeah, United by Blue has stores all over the place. So also, for example, in Manhattan, there's one store. What I would like you to take away from this slide is really that there are these two channels and two types of people who can contribute to a campaign: donors and people who actually want to buy the product. So what we do now here in our paper is that we introduce a new type of a contribution game motivated by Kickstarter. And so this is not a classic public goods contribution games as we know it from the literature, such as Sinat Mati Perry or Fetchman Nitzan, but it's excludable good. So it's a private good that you sell, and you can only consume the product if you actually participate. And so here the key tension is really one of coordination among buyers rather than a free riding problem among buyers. And of course, there are, though, these donors. So we also want to introduce this interaction, and that's another difference to classic contribution games. And these donors are important. Just as a preview, I show you more data later, but 28% of revenues actually do come from donations. And the idea here is that maybe these donors can alleviate the coordination issue that the buyers are facing. So as I said, the paper is pretty big, and I will see how much time I can spend on what part. So I might have to skip over some things in these 45 minutes. But what we do is, so we introduce this new type of contribution game with a long-lived, privately informed donor and small buyers who are interacting with each other. We're interested in how the dynamics of the contributions evolve over time as information is revealed. And then we solve for equilibria, for a bunch of equilibria, which, because it's a signaling game, yeah, we look at optimal equilibria for the different players in this game. And then because all these equilibria turn out to have a very nice and similar structure, it allows us to derive testable predictions for these optimal equilibria. And then we also collected and analyzed novel high frequency data from Kickstarter, and yeah, show that our equilibrium predictions are consistent, or how far they are consistent with the data. And while we are really just analyzing a dynamic game, it opens up a bunch of interesting questions in the mechanism design domain. We only have a limited exploration of it, and I won't talk about it at all in this talk, but just to give you some examples. So one is, I mean, you could think of having a donation campaign first and then a buyer campaign. Those types of sequential things perform strictly worse for everybody. So it's better to have like this dynamic interaction between the two types of players, showing less information to buyers, so not letting them know as much about the progress of the campaign can be good or bad for them. So that I will also, we have a very small analysis on that. And then we also touch in the paper up on social learning, but in the main part, there's no uncertainty about quality. So we are, yeah, the main idea that we are discussing here with respect to the interaction between donors and buyers doesn't contain social learning. I can, as a preview, I can tell you, if you add uncertainty about quality, basically this role of a donor as a coordinator for buyers becomes weaker. I will not talk about the literature a lot. I mean, yeah, so Matthew has a nice paper which deals more with versioning or people paying more than their willingness to pay. I think, yeah, then the seminal paper is, which is published, the first paper was by Strauss in 2017, a very nice paper which looks at moral hazard, concerns of the entrepreneur. And then I think in terms of modeling, we're pretty close to this operations paper here, but they also don't have a donor. So let me just go right into the meat of the paper. So I will, what I will do is I will start with stylized facts and then go into the model, show you the theoretical results, because they're important in order to get to the testable predictions. I selected a few for you for this talk because, yeah, I won't be able to cover everything in 45 minutes. Okay, so what is the data about? So we are basically tracking the entire Kickstarter webpage every 12 hours from March 2017 to September 2018 using a web scraper. So we have all the prices, quantities, essentially everything that the customer can see, and a little bit more what is in the HTML file. So, and also product characteristics. Yeah, and so we have about 3.9 million observations on the campaign level. In terms of summary statistics, one thing that I would like to emphasize here, so what this is just for all campaigns, unsuccessful campaigns, successful campaigns, and then median and some percentiles. But what I want to emphasize here is this number that for all campaigns, yeah, the percentage of revenue coming from donations is about 28%. For unsuccessful campaigns, it's higher. For successful campaigns, it's a little bit lower. Maybe one more interesting empirical fact is that most campaigns really last for 30 days, even though the entrepreneur can choose how long a campaign lasts. And the entrepreneur in principle can choose between 0 and 60 days of length. And there is some variation, but a lot of bunching around 30 days. And then also in terms of the different categories that are out there, so the percentage of donations coming from, percentage of revenues coming from donations is really high across categories. These are the 3 biggest categories in our data set. And even the design has 16%. And maybe technology, which is one that might be interesting to many, is almost 30% in terms of revenues. And so let me now just walk you through 3 kind of facts and observations that that motivate our modeling. So first, this has been documented in other empirical papers on Kickstarter. So on the left-hand side here, I have plotted a histogram for the revenue as a percentage of the goal. So in particular, what this means is that 1, you just reached, these are the campaigns that just reached the goal. Everything to the right of 1 are the successful campaigns. Everything to the left are the unsuccessful campaigns. Interesting thing here is that there's bunching at 1. So many campaigns just reach the goal. There are very few campaigns that reach 80%, 70% of the goal. And so the unsuccessful campaigns really are unsuccessful with very, very little money raised or percentage of the goal raised. And then here you have a very long tail. So some campaigns are extremely successful. And so we cut that off here in this picture. And then on the right side, another fact that has been documented is that the time at which a campaign becomes successful is kind of U-shaped. So some almost instantly become successful, some, and then, sorry, it's not some, many become instantly successful, many become successful just at the deadline. But then there's a lot of dynamics going on in the middle as well. And so what we are interested in is really kind of explaining this spike, and then also why there are so many successful campaigns becoming successful just at the end. There, the donor really plays a very important role. And then we also, of course, are interested in the middle. But that will become clearer later. And these facts were hard to explain without having a donor. Another fact here, which has also been documented, is that, the mean contribution count is also U-shaped. So basically, there's a lot of action at the beginning, a lot of action at the end, but throughout also action. Okay. And so what we did is, as a first step, just to get an idea, and what really motivated this paper is to split the dynamics up into donors and buyers. So here on the left-hand side, we have the donor contributions as a percentage of revenue over the lifetime of a campaign, restricting attention to those campaigns that last for 30 days. And furthermore, we split it up into campaigns that finish in the last 3 days. These are the late finishers. Campaigns that finish in the first 3 days, so reach the goal in the first 3 days, and then everything, the middle finishers that are somewhere in the middle. And what you can see here is that the late finishers really are the only ones that have this spike in contributions close to the end. At the same time, to the right-hand side, it's the same graph for the buyers, and there is a little bit of a spike at the end, but there's not much difference between late finishers, early finishers, and middle finishers. And then, of course, there's also a spike here at the beginning for both buyers and donors. I will not, in the model you will see, we won't talk about the spike at the beginning. Again, in the extension section, we talk about like varying arrival rates of buyers, but and advertising, but we won't, I won't talk about that in the talk. I will, however, discuss a little bit where does the spike, the slight spike could come from for donors. Right, and so one takeaway from these facts is really that early successful campaigns have a lot of buyers, so they're driven by buyers. Late successful campaigns are driven by donors. There's a lot of action here, but both occur throughout time. Here again, like this is the same thing, just as a summary table. But if you look at the revenue as a percentage of the goal, you can see that, well, early finishers have the highest revenue, late finishers have just reached the goal. In terms of donations, late finishers have a high percentage of revenue coming from donations versus early finishers. For them, donations are not that important. And then the third fact, we wanted to get a little bit at, okay, what is the incentive of donors? Is it really, what do they care about? And I mean, our hypothesis is that it's friends and family who just want to help the entrepreneur to be successful. And so what we drew here is just, so 0 is the time at which the goal is reached. the 12-hour window in which the goal is reached, and then 3 days before and 3 days after. And so the gray line here is donations, and the donations are positive before success, but then essentially drop to 0 after success. And there's a drop also for buyers, but you can see that basically the difference, I mean, after success, most of the revenue is coming from buyers rather than from donors. So it seems like donors really care about making a campaign successful, yeah, we have a little bit more details about it in the paper, but I think I won't even talk about it in the testable implication section later. Okay, so these are the facts. Questions?
You're good to continue. It's very
I'm
clear.
good to continue. Excellent. Okay. So what are the key ingredients of the model? So it's already basically what I emphasized in the empirical part. So there's a goal amount, there's a deadline, and there's a price. And then we have two types of players. One is a long-lived donor who represents all the friends and families. And then we have consumers who are arriving over time at a rate lambda. It's an all or nothing mechanism. So if the goal is reached by the deadline, then buyers get the product. And if the goal is not reached, then all the transactions are void. So the donor gets back the money and the buyer also gets back the money. The timing, so we're analyzing a discrete time game, but sometimes in the paper we take limits just in order, because the formulas are much nicer. It's much nicer to look at Poisson processes than to look at like binomial distributions. But so the game that we analyze has like a campaign length of delta. The timing within each period is that first the buyer moves if the buyer has arrived and can either buy or not buy. Actually, we don't restrict attention to pure strategies, but I will mostly talk about pure strategies because it's easier to understand once I talk about platform, donor, and buyer optimality, and we allow for mixed strategies too. But they're not optimal. And then after the buyer makes a decision, then the donor has a move. So the donor, at the end of every period, the donor has the opportunity to throw in more money in order to keep the campaign going. And what we keep track of will be the aggregate donation amount, which we denote by big capital DT. And so this process must be weekly increasing. So you cannot take out money as a donor. The payoffs are as follows. So the buyer's payoff is, all the buyers are the same. If they pledge and the campaign is successful, they get the value for the product V. Again, we don't have social learning here in the main model, so it's just a fixed V that everybody knows, minus P. If the campaign fails, but they have pledged, they get 0. However, if they decide not to pledge, then they can just have access to an outside option. You can also think of it as just typing in the credit card information. There's some transaction cost of pledging. So you want to only pledge if you think the campaign is sufficiently likely to be successful. So that's kind of the point of this payoff function. The donor's payoff is as follows, or a little bit simpler in the sense that the donor has some valuation for the campaign and has put aside this money for the campaign, which we denote by W. I will call W mostly wealth, because it's easier intuitively to think about it as in terms of wealth, but you can also think of it as the value for the donor. And this is his private information and distributed according to some CDF F0. And so then the payoff is the value or the wealth W minus the total donation amount made at the deadline. So how much they have contributed in the very end. He has contributed at the very end, so W minus DT, if the campaign is successful. If the campaign is not successful, the donor gets back all the money, and so the payoff is 0. Okay. So again, just to have a picture, so the way it works, we allow actually the donor to make a donation at the very beginning too, simply because that makes the formulas more consistent over time. So the donor makes a donation at the very beginning, then the buyer moves, then the donor moves, then the buyer moves, then the donor moves if a buyer arrives. Okay. And so the histories are basically defined like the classic way as we would define it. So buyers see all the aggregate people who have purchased already and the aggregate donations for each periods before, for every period before. And the donor has one more observation when the donor moves because the buyer has moved in the same period. So the donor also sees how many pledges have been made in the period where the donor has arrived. The strategies are just mapping those histories to either 0, 1 or the interval of 0, 1 if we allow for mixed strategies for buyers. We denote those strategies by B. The donor strategy, we keep track basically of the aggregate donations, so it maps the history and the type to the aggregate donations where you cannot take out money for it to be feasible. And buyers also must form beliefs here because the donor has this private information about W. So given a history, we call the belief F tilde. So we're interested in classic PBE, but then it turns out that these optimal equilibria that we will be looking at have a very nice, or the optimal outcome can be attained by stationary equilibria, and they are stationary in the following sense. So the state, all the strategies are just a function of the state X, which is given by the number of pledgers or buyers who have pledged already, N, then the aggregate donations D, and U is the time that is remaining from the deadline. And then we can essentially, because often on path, it will only depend on X, we can basically describe all the strategies just by functions from the state to the corresponding spaces. But I won't be able to actually go that much into detail in this talk, but I wanted to mention just in terms of the framework. And then what we're interested in is really, because we have a lot of equilibria, platform optimal equilibrium. I mean, there's no platform moving, but we call it platform optimal, the equilibrium that maximizes the probability of success of a campaign. Then donor optimal maximizes the donor's payoff, and buyer optimal maximizes a buyer's ex ante payoff before a buyer is basically thrown into the campaign. I mean, they arrive according to a Poisson process, but you can think of it as, the distribution is the same as throwing a certain number of people in randomly. Okay, so these are the equilibria that we're interested in. Now let me just quickly talk about kind of the tensions here, and then we will have another question pause. So the key tension in all these equilibria is really that a buyer is thinking, is it sufficiently likely that the campaign will be successful so that I want to incur this opportunity cost V0? And the donor is just thinking, how much do I need to donate in order to keep the project going? And then, I mean, kind of the IC constraint or the equality that describes the buyer's behavior is very simple. So it's just kind of the probability of completion or the probability of success of a campaign, which we denote by pi, times as a function of the state. So here I already restrict attention to stationary for the slide, times V minus P, which is the value that I get if the campaign is successful. And that should be greater than this outside option V0. However, what makes everything so complicated is that, of course, this depends on the equilibrium that we're playing. It depends on how much time is left, how many more people will arrive, on the wealth of the donor, and so that's where kind of the meat is of the problem. So the main challenge is really, I mean, we have a pretty rich state space even for stationary equilibria because we have to keep track of buyers and donors. So it's not the classic proof of contribution games. And then when we also need to make sense of all these different equilibria that exist in dynamic signaling games, typically. Okay, so I have another break.
So unless there is a technical glitch, you've done a successful job of everyone being on the same page with you. There are no questions yet.
Oh, wonderful. Okay.
Yep.
Okay, so let me move on. Then, so I won't be able to go through the construction of the equilibrium, but even like looking at the game without a donor gives you a sense of what numbers are important, and then I will just briefly tell you how the construction would go if there's a donor. So as a benchmark, let's just think there's no donor. So there are only buyers who want to buy the product. Let's assume that the number of buyers that are needed is M0. So now imagine you're the last buyer who arrives and you can make the campaign successful. Then you know if you buy, the probability of success is equal to 1. So you definitely want to pledge. So the last buyer will always pledge. And now we can do an induction in how many more buyers are needed. So the M0 minus first buyer knows that she cannot complete the project, but the next buyer will be able to complete the project. And the next buyer will definitely buy if I pledge. So the probability of success will be, and let's just look at the limit here because it's easier, that one more buyer will arrive in the time remaining, and the time remaining is you. So this buyer will pledge if and only if 1 minus e to the minus lambda u, which is the probability of success, is greater or equal than v0 divided by v minus p. v0 is the outside option, so now I just put v minus p to the other side. And so what this psi is, it's just the time at which the latest time, or the time from the deadline, the smallest time from the deadline, so that the M0 minus first buyer still wants to pledge. So if less time is remaining, then even if the M0 minus first buyer arrives, this buyer is not gonna want to pledge anymore. So basically the key numbers that we want to keep track of is really this probability of success, and also these cutoff times xi, sorry. And xi2 means 2 more buyers are needed. So, and xi3 would be 3 more buyers are needed. So we need to construct all of them. I have a 0 here because in the full game, if we have a donor, this cutoff will depend on W. So it will depend on the wealth of the donor. If the donor realization is so that the donor has a lot of money, then you can wait until the end and still the campaign will be successful. Otherwise, it cannot be successful. So actually, in the actual construction, this will be unknown to the buyers, but known to the donors. Okay. And so the recursive construction will then be, if we have M0 minus J more people needed in order to make a campaign successful, then you can kind of inductively, you can use the expressions for if we need M0 minus J minus 1 people, and using this cutoff, I mean, those people, the next buyer must arrive in time, and so you can calculate recursively these probabilities. This also allows you to, again, calculate these cutoff times, and you can describe the entire equilibrium. And of course, now if we have the W as well, we also need to keep track of beliefs and stuff, so that will make the construction a little bit more complicated. And so in particular, what we will do when we have a donor is that instead of doing the induction in the number of buyers needed, we do the induction in the number of buyers needed given the current level of donations. So if currently D donations have been made, then we need G minus D divided by P more people if no additional donations are being made. And so we will make an induction in this number, or this number minus N, actually, because some buyers have already arrived, which we denote by J. Another interest, I will show you the structure of the equilibrium in a second. Another thing that, another property that all the equilibria, these maximal equilibria will have, they're not only stationary, but we can also, the optimal outcome can also be attained by an equilibrium where donors play a very nice strategy, which we call pooling threshold strategy. So a pooling threshold strategy is a strategy where the donor always makes sure that at least D star of donations are made. So you always want to meet this threshold as a donor. And so if you're already above the threshold anyway in a state NU, then no need to donate. But if you haven't met the threshold yet, then you need to donate. So either donations remain constant, no additional money is being thrown in, or you just make sure you're at this threshold. And basically, yeah, if you imagine like many buyers arrive suddenly, it might, yeah, anyway, no, I shouldn't say that yet. But so this is the threshold. So a pooling threshold strategy is such that you always want to donate at least D star as long as you can afford it as a donor. So donors might run out of money and not be able to afford it anymore. And so what we will do is we will construct basically two stationary equilibria with pooling threshold strategies and then show that one of them is platform optimal and donor optimal. Actually, this will be the one where buyers have very optimistic beliefs, meaning this threshold will be as low as possible. And then we will construct the other equilibrium will have the property that buyers are maximally pessimistic. So basically the donor has to donate a lot in order to keep the buyer buying. So that's the buyer optimal equilibrium. And I will have a slide on that in a second as well. So the main idea now is really in the proof so we will construct these types of equilibria, and now for the construction, really we do an induction in this J, which is the number of additional buyers needed given the current donation level, and then in each step, within each step we also do an induction in time and construct the probability of success, this threshold D star, and the Xi, the cutoff times. So here I just want to visually, I didn't put the proposition in the slides because of the time constraint, but here what you can see is basically the length of a campaign, the timeline from 0 to big T. The blue dots are realizations, arrival realizations. Imagine we're in a world where, given the donor wealth realization, we need exactly 5 buyers in order to complete the campaign. And then I have kind of Xi is the time away from the deadline, so that the second but last buyer must arrive, such that the third but last buyer must arrive given this W. And so what you can see here is, given this buyer arrival realization, the first guy has arrived in time. The first guy is if 5 more people are needed. But when 4 more people are needed, so the second guy arrived too late, and so the campaign is dead. So with this realization, what will happen is all these people will not buy. If this guy arrived earlier, then the campaign would have been successful. And so this is also basically, this dynamics is also what leads to this spike, to the fact that many campaigns fail with very little money raised, because basically the timing matters, and people need to arrive sufficiently early. I'm wondering, maybe I should make a break now already, because I will now go to platform optimality, which is a little bit of a new idea. So I will change a little bit plans. Shannon, are there?
So Larry White actually has a question on the opportunity cost for the buyer. So the question is, since the campaign duration is only 30 days, and if the buyer can get their money back within 30 days of the project, isn't the opportunity cost quite low?
Yeah. I mean, you can think of it as either just transaction cost. You need to sign up, you need to put in your credit card information, you just need to make the effort to actually pledge. The other, the other cost could be, I want to buy this bike back, and I want to know whether I get it or not. I have made a search. I have an alternative that I could get. If I think it's very unlikely, why should I wait? Right. So I agree that we allow actually for the outside option to also vary over time in an extension. And that's a key here, that really buyers only want to pledge if they think the campaign will be successful. Otherwise, the dynamic doesn't work. But yeah, it's a very valid point.
And so, and I hear the clarification from me is you're assuming the buyer has to make this once and for all decision, right? They cannot come back.
No,
and so
yeah,
which we can think of as opportunity cost of having to think about this and refreshing the web pages a lot. So
yes,
makes sense.
Yeah. And also, it doesn't seem to be empirically the case that people are really coming back much. I mean, here we don't observe individuals coming back or not, but yeah, we can, I think in other pricing setups too, people do search, but then oftentimes you just do it once and don't want to monitor throughout. However, actually Kickstarter does have the option to remind you close to the deadline. And we found out about it quite recently, which is an interesting feature that I think we should explore a little bit more. But if that is the case, there should be much more bunching at the deadline of buyers, which we don't see in the data. All right.
If I could add just very quickly, in a sense, this remind me option does support the idea that it is costly to come back. It's a hassle to put it in your memory. You've got to be there by the deadline. And the fact that what you empirically show, not that many people use it. So I think, yeah, that's not a problem for what you're doing.
Yeah, yeah. Which is interesting, because I think we always care about making buyers forward-looking and being able to come back. But maybe there are other dimensions that are more first order when people make these dynamic decisions. Yeah. All right. Any other? Awesome. Beautiful. Yeah, so the platform, this was actually what we were working on for a year, because the first submission that we did, we realized that there's an error because we thought all equilibria have this nice structure, basically with pooling threshold strategies. Turns out that lemma was wrong. And so we needed to come up with a completely different proof. And what we did is, so in order to show that certain equilibria are platform optimal or buyer optimal, we needed to transform the problem. Because remember, like if you want to prove that something is platform optimal, you need to see what maximizes the probability of success among all PBEs that are out there. So what we do is, we simplify the problem for the platform in the following way. So first of all, we observe that platforms do not care actually about the donation amounts. So what we can do is, instead of looking at the full histories, we look at reduced histories where we only keep track of whether a donation would make the next buyer buy or not, given an assessment. So for each assessment, you can, instead of reporting NDU, we report only N, and then whether the donation given this assessment would make the next buyer buy or not. So then it's just a 0-1 variable. And then the other thing is that then instead of having as a choice variable the PBEs, we have as a choice variable the probability of reaching these reduced histories. So, and of course, the probability of reaching different histories is essentially like governed by the beliefs of the buyers. So a different way of thinking about it is, this problem is really choosing the dynamic buyer beliefs rather than, so basically the platform could choose dynamic buyer beliefs given some consistency constraints that we of course have to impose. So we kind of formulate this relaxed problem, solve the relaxed problem, but then show that the equilibrium that we construct is actually attains this maximum. And so then we know that it's platform optimal. So that's kind of the strategy of the proof, but I won't be able to go into details. And then for donor optimality, it turns out, I mean, you might think that a donor could actually benefit from maybe not donating, not making a buyer buy tomorrow, but then donating again later, or by like but basically what we show is that the donor cannot do it, and we can use the idea of the proof for platform optimality, because choosing the beliefs and choosing the donation amount turns out to be quite orthogonal problems. So the proposition is that the stationary platform optimal equilibrium is also donor optimal. And then for the buyer optimality, the proof is much simpler, and the reason is that actually this buyer optimal equilibrium is such that the buyer acts as if the buyer knew the realization of W. So the idea is essentially that on equilibrium path, if a buyer buys, a buyer would even buy if there was no donor, if the donor was out of money. Of course, on path, the buyer strictly wants to buy, but but he would have bought even if he thought, if the beliefs were very pessimistic, or if he believed the donor has run out of money. So put differently, on the donor and platform optimal, for the donor and platform optimal equilibrium, the donations will make on path the buyer just indifferent between buying and not. For the buyer optimal equilibrium, the donations will always strictly want to make the buyer buy, such that even if the buyers believed the donor has run out of money, they would still buy. And so these define the two kind of boundaries of these that can occur. Okay, so yeah, that's it. Any questions on that?
So we don't really have a question from the chat, but I do have a question now that we're talking about the platform platform optimal equilibrium and the donor optimal equilibrium, because I remember in my work with Kickstarter, they have the feature that you can take out your pledge anytime you want. And so now that I imagine myself being a donor, and once I tricked the buyers to push the project over the threshold, I could just take my donation back.
Right.
Isn't that a
so the thing
concern?
is, right, but that's also another thing. Yeah, you do have the option, but it's a hassle, and we don't see donors taking money out. Actually, also when we wrote down the model, I mean, we don't see many observations where donors, where the donation amount goes down from one period to the other. But yeah, this is also something that we found out after actually writing the paper or having the first version of the paper. The interesting thing is that the equilibria that we characterize would also be equilibria if the donor could take out the money, exactly because not being able to, I mean, of course, the donor would then take out the money, and we would even see more just reaching the goal. And actually, successful campaigns should not have any donations, or only donations up to the goal amount, and we don't see that either. I mean,
I think this one actually doesn't affect your analysis, because this is not a learning problem. And so the buyers are happy that the donors help them coordinate their efforts and push this successful. So this is relatively fine in your setting, I suppose. Yeah.
Yeah, and I guess what I wanted to say is also, right. So the buyer behavior and the outcomes will be the same in your game and in this game.
That's right, for the buyers.
For the buyers, because donor optimality and platform optimality turn out to be the same. But it's absolutely. So excellent. Maybe also just one thing, which is also interesting, more from an empirical perspective or just conceptually. I mean, this buyer-optimal equilibrium is also equivalent to an equilibrium where buyers would be equilibrium to a situation where buyers just don't believe there is a donor. So they just get surprise bumps in getting closer to the goal. That would be exactly the equilibrium or the outcome that you reach if we are in the buyer-optimal equilibrium. All right, so now I only have 3 minutes, and I just want to show you a little bit of the testable implications. I mean, of course, we have some stuff on comparative statics. I just want to give you a flavor of what we're able to do, because of course, I mean, we couldn't write a structural model here that we can estimate, because there's so many different parameters that are not in this model. But what we did is, so for example, one obvious thing is that the ex-ante probability of a success of a campaign should be increasing in time and decreasing in the goal, because exactly buyers care about the probability of success. In order to test this, of course, the ideal experiment would be to launch like 2 identical campaigns and just vary kind of this parameter. We're not able to do that, but what we did is we looked at repeat campaigns, so campaigns that were not successful and then were relaunched later and then became successful with a higher T or a higher goal or a lower goal. And so what we see is, so people just don't vary T much. So actually there we don't find any significant results, but indeed the campaign, when it was relaunched and was successful, the goal amount was $50,000 lower, and it was statistically significant across campaigns. Another thing is that we ran, because we have all this information, we could run this model of predict basically the probability of success given all kinds of product characteristics. We did a lasso regularization, but just kind of in terms of, we wanted to see, is it better to, if you're closer to the deadline, you should also have the probability of success should be lower, or if you have more revenue, the probabilities of success should be higher. And if you kind of write this empirical, very simple model, so we do have one logistic regression, I guess, even though we don't have a structural model. What you can see is that if you're a day from the deadline, then the probability of success, sorry, not a day, sorry, if you're 29 days from the deadline, so if you're close to the beginning of the campaign, this is the probability of failure now. So you're likely to succeed only if you have at least reached 20% of the goal. Also consistent kind of with stuff that I showed you before, and even Kickstarter has this on the campaigns, used to have this on their site, that they said, you need to reach 20% of your goal in the first couple of days in order to be successful. So that you can see here, and the closer you get to the deadline, the larger the probability of failure becomes. Sorry, this was a little bit confusing. And at the same time, so on the horizontal axis, we have the percentage of the goal reached at that point in time, and you can see, the lower the revenue, the higher the revenue, the lower the probability of failure in this empirical model. Some other predictions are, and I should stop soon, is, well, the campaigns that succeed in terms of donation dynamics and also what successful campaigns look like. Indeed, campaigns that succeed at the deadline raise exactly the goal. We find that in the data, at least 66% of campaigns would have failed without the donation. If a campaign succeeds before the deadline, then it becomes successful because a buyer has arrived. Because a donor never wants to make a campaign successful prior to the deadline. A donor always wants to wait until last minute and donate only if necessary. And so in that sense, so what I have here is the percentage left of the campaign. So it means this is kind of exactly at the deadline, and this is at the beginning of a campaign. The theoretical prediction is that buyer revenue in the period where a campaign becomes successful should be 100%. So the theoretical prediction is horizontal line and then something between 0 and 100. Indeed, in the data, we see that the 75th percentile follows that pattern pretty closely, but you can see the 25th percentile is completely off. So you can see there's, of course, variance. But it seems like if you get successful in the middle, it's because of buyers, at least for half of the campaigns. And let me skip over these things. We looked a little bit at donor dynamics too. And let me just summarize. I can get back to it maybe in the discussion if there are not that many questions. But to summarize, so what we did is we introduced this new class of dynamic contribution games with private benefit and positive externalities, where coordination is the issue rather than free riding, and where basically this donor can alleviate the coordination risk. Then we show that the equilibrium predictions match the data quite closely, in particular for successful campaigns and donor dynamics. I think in terms of insights, it's that the donor can help to alleviate coordination risk, and that kind of this dynamic donor-buyer interaction is really what drives a lot of the dynamics that we had observed in aggregate summary statistics in other papers also. And let me just skip over the other results. I think I mentioned them already. And I think, it opens up interesting maybe other games that one could analyze, where you have like a long-lived player who's kind of monitoring a game and helping out smaller players. Thank you so much.
Thank you. Matthew.
I think
Matthew, you're muted. Okay, I think you're fine now.
I'll try again. Thank you. So it's been a real pleasure reading this paper. It's extremely well written. It's an extremely impressive data effort, and I really like it. I think crowdfunding, let me just give a little bit of background. The crowdfunding is really important. It's grown a lot thanks to the internet, but it really can help entrepreneurs get their products out because it gives an incentive compatible market test before the entrepreneur has to sink their costs of actually producing the good. I think my paper with Jacques Herkins, where we've actually proved that a static setup is optimal. So we take mechanism design approach and show that static is optimal because we don't have these bidding costs. So I think you've done the minimum, the most parsimonious extension of adding this bidding cost, simplified by just taking one type of buyer who only write a positive value, which is the same setting that Roland Strauss did, right? And I think this cost, it's very intuitive that it makes sequentiality optimal. The reason is that if over time we see that very few buyers have arrived and bidded on the project, then the later buyers should save their cost of bidding because the project is unlikely to succeed. So you have a result in the paper on showing that success rates increase with sequentiality. So I think that's very nice. I think the theory results are extremely clean. I think it's where you explained how you managed to solve things using the relaxed problem. I've actually been working on the same topic with a PhD student called Michele Fabi, who's on the job market this year, so an excellent candidate to anybody looking to hire. And what we do, there's a strong overlap. I just mentioned one thing which we totally abstract from the donations. So you've totally convinced me with your data and other work that donations are important. We could only solve without donations. And so it's really impressive that you managed to crack the tougher nut. Fortunately, we're still complementary. One quick complementarity that I should mention for Larry's question is that we model the inspection costs. So the very fact that crowdfunding, it's a product that hasn't yet been produced, means that it's more difficult to work out whether you actually like the good. And therefore, inspection costs are quite big. So Larry was saying, well, these opportunity costs could well be very low. But inspecting, that could be quite expensive. And we actually proved that in the main case we treat, it becomes equivalent to this bidding cost, opportunity cost that you model. So overall, it's a very intuitive analysis. You have this single donor who basically wants success. And she's going to kickstart at the beginning. That's the initial spike. Then she's injecting funds minimally, just on this as-needed basis, to keep the project alive. And she fills up to reach the goal at the end, if that's necessary. And all of this, of course, she does while she can, while her wealth or her motivation permits her to keep donating. So when you look at the essentially the continuity in time, you can see why you get this minimal topping up during the campaign, which explains the peaks at the end of the beginning. And it's, I think, very well backed up by the data. So I have a couple of comments on the data, but let me focus on the theory, which I have studied more myself. There's a minimum, the multiple equilibria that are natural with these signaling problems. And I think one comment is that the fact that the donor and the platform have the same preferences, that you get the same equilibria, whether it's, in fact, as you claim, the entrepreneur self-bidding would give the same. So this is attention, I think, that a more realistic model, you would get some differences. It's much too difficult to do, I think, in this context right now with an explicit solution. But I think it would be good to discuss, because there's a data paper that I'm going to mention later, which I think deals with a German platform called Start Next, where they actually do allow self-bidding. So Kickstarter doesn't allow donations by the entrepreneur, whereas this German platform does allow it. And there's a nice data analysis, nothing like as rich as yours, but Crosetto and Regner in Research Policy 2018. I would recommend you take a look at that. They basically find a U-shape and have some results where they look at self-bidding, because for them it's very easy to assess donations by the entrepreneur, because these are reported. Let me comment one other thing on the theory. That you also have a very nice summary of why the buyers, they prefer the front-weighted donations, because which rises when the buyers are pessimistic, forcing earlier top-ups by the donor. This is very intuitive that the buyers, they care about their sunk cost. So I think a really intuitive, nice theory. On the motivations, let me come back to that, which I think is quite a big issue. I think it's because you have this cost is deterministic. Okay, so this is the big ascension that Michele Fabi and I are doing. We allow for a stochastic distribution of this cost, right? Some people, they find it very easy to inspect because they find it fun. It might even be negative. in the sense that they enjoy inspecting. What happens in your analysis, I think, right, it's probably necessary. It'd be great if you can progress with that, but I don't think you need to, since the paper's so nice already. But I would say you would get differences, right? That you find there's no trade-off based on the different motivations. There's no trade-off like, do I donate a bit more to have a higher success rate? And the reason is that it's either alive or it's dead. It's because you know the exact cost of the bidders who are arriving, and so there's no point, right? You can't get more bidding by donating above that minimum in any of the equilibria that you look at.
No, so, exactly.
Sorry?
Sorry, I started responding, even though I just wanted, yeah, I'll respond to it after you're done. Because it's a very good point, yes. Mm-hmm.
So, yeah, on the Crozetta Regna, it'd be great to see if you get a difference, because there I would say, why does Kickstarter not permit self-bidding, right? In a sense, that forced you to do this amazing data effort of really distinguishing donations from buyers, donors from buyers. And I think in your model, there's no reason. In my paper with Jacques, the JET 2019, the entrepreneur could gain from not being able to self-bid because, right, not donate to herself, because it allows her to commit to a higher threshold, and that can extract more rent from the buyers. In your context, I think it cannot happen, that you don't have a reason for it, but it might be good to investigate, particularly in order to compare Start Next with Kickstarter and any differences you may find with the Crozetta Regna paper. Multiple donors, obviously, you recognize that that's a lot harder. There will then be free riding. I think that would be excellent future work. Again, I think it's much too hard to expect you to add that in your setting. In the dynamic context, I have a couple. Yeah, because I think time is running out. So let me just say on the empirical side, another key simplification in your analysis is you take the goal as exogenous, right? The entrepreneur actually would be setting this goal. Imagine you know that there are some rich donors out there. You have some rich family who you want them to give you, help you, giving you money. Well, you may set a bigger goal if you know that they're going to back you up with high donations. Also, the entrepreneur may be able to signal that. So in your analysis about signaling, if it's your family, you're going to know more about them than the buyers, so you might signal it. Anyway, the main point would be that you can get reverse causality. So some of your correlations in terms of the goal size and the size of the donations, I think are to be taken with a pinch of salt. That clearly would rely on endogenizing the objective of the entrepreneur in order to study how the goal will interact with W. And I think common values is a thing you've called social learning. It's really nice that you managed to model even that case, but you did a very stylized case of that, and I think Shannon has worked on this. There are a number of others. I think, again, for future work, that would be excellent to understand better what is the role of common values in this context. Let me just say one quick remark. I'd be interested in your reaction. So many people think, okay, herding, what's going to happen with herding? Can that explain the U-shape? Well, it can explain the U at the end, and maybe you have contacts bidding at the beginning. So, sorry, it explains going up towards the end, but what about the beginning? So this Kupuswamy and Vios paper that you cite, which has data from Kickstarter, and they use the family name. Now, that before 2012, you're able to look at the family name, so you can guess these are donations. And I think, right, that's no longer the case. Does it mean there was no herding reaction in the Kupuswamy Vios data thanks to the fact people knew these are family, they couldn't see by the name? Whereas after 2012, which made your lives harder, that information isn't there. That's a mild idea I had just now, and I stopped there because I'm out of time. But thanks very much. It was a fantastic paper and very, very nice presentation.
Thank you, Matthew. There was a referee report type of discussion right there. So we're right on the clock, but Aniko, I want to give you just like a minute to respond, and maybe then we can have a sort of free chat. And for those who have,
yeah, I think there were so many points. So I think maybe is there any other question? Because I feel like it's probably. I was thinking, I even forgot for the outside option. I mean, we do. So basically, the main difficulty, everything that all the assumptions that we make have to be so that this pooling threshold structure doesn't get destroyed, and we don't want these thresholds to depend on a more even richer state space, because it will make things even more complicated. And if you have, we can allow the outside option to vary over time to a certain extent. If it becomes very random, or if we add like these additional layers, essentially that's where things become more complicated. This pooling threshold structure will become even harder than it is already. And yeah, so but it's a very valid point, and we were kind of making assumptions to make it tractable while seeing something interesting in there. But yeah, thank you. It was a great discussion. I will maybe talk to you later to hear more as well. Yeah. Thanks.
Okay, so we're 1 minute past 11, and this has been fantastic. And for those of you who have time to hang around, I suppose, Aniko, you have still a few minutes to have more discussions. Yeah, we'll do sort of unofficial Q&A now. So I'll start with the first question. So I was fascinated by the fact that you're able to draw some implications on the optimal design of the either information design or the platform design. Will you be able to talk more about that? You have to